Let's position it here. All right, so what we have is it says a freight train left the station and traveled toward the repair yards. A diesel train left 6 hours later traveling at 30 miles per hour in an effort to catch up. That's a very, very important sentence right there. In an effort to catch up. All right, so what we have here, we've got a freight train, let's call that F, and then we've got a diesel train here, let's call this D. All right, so the freight train left the station, traveled towards the repair yards. A diesel train left 6 hours later. The diesel train left 6 hours later. So we've already talked about last week that these are distance is equal to rate times problems. D is equal to RT. Distance is equal to rate times time. This says that the diesel train left 6 hours later. So the way I'd like you to interpret that is if the diesel train left 6 hours later, that means that the freight train was on the tracks for 6 hours more than the diesel train. So let's just call this T. Let's call this. Let's deal with the time a little bit later. It says after traveling for 4 hours, the diesel train finally caught up. So the diesel train was traveling for 4 hours. The diesel train was traveling for 4 hours. And the important sentence here is it finally caught up. So what that means is though the freight train left first, the diesel train left some time after the freight train. The important sentence here is after traveling for 4 hours, the diesel train caught up. So what that means is that because the diesel train caught up, the distances will ultimately be the same. That's an important fact that we'll take advantage of. All right, so after traveling for 4 hours, the diesel train finally caught up. Find the freight train's average speed. All right. So the diesel train left 6 hours later traveling at 30 miles an hour. So they're telling you that the diesel train was traveling at 30 miles per hour. They also told you that the diesel train was traveling for 4 hours. You know that distance is equal to rate times time, so you end up with a distance, the hours cancel, of 120 miles. All right, so the diesel train was traveling at 120 miles. Earlier in the problem, it says the diesel train left 6 hours after the freight train. If the diesel train left 6 hours after, that means the freight train left first. So what you would do is if the diesel train was traveling for 4 hours, the diesel train left 6 hours after the freight train. That means that the freight train was traveling for 10 hours. The freight train was traveling for 10 hours. All right, so you'd substitute 10 hours into the freight train's time. You know that the distance that the diesel train traveled was the same as the distance for the freight train. Again, because it says after traveling for 4 hours, the diesel train caught up to the freight train. So you know that the freight train distance is 120 miles. So you end up with an unknown variable being the rate. So what you have is you have this algebraic equation, 120 is equal to the rate that they want you to solve for times 10. So you solve for R by dividing 10 on both sides, and you're left with R is equal to 12. 12 miles per hour would be the proper units there. All right. So the key here is that they told you that the distances ended up being the same because they said that one train caught up to another. So the distance in the freight train had to be equal to the distance in the diesel train, and that was the key to the whole problem. They gave you the rate and the time for the diesel train. We calculated that distance there, and that same distance had to be equal to the distance of the freight train. And this time they told you that the diesel train ended up leaving after the freight train, so we just added 4 to the 6 to get the 10. All right, so what I'd like to do is to go through another problem. We've got plenty of problems to go through. All right, so let's look at this problem here. This is number 5. All right, let's take a look at number 5. All right, I know it's small, but I'll read it. To you. All right. So it says a cruise ship. Okay, it says a cruise ship left Hawaii 10 hours before a submarine did. Notice how this problem is a little bit different. It says the ships traveled in opposite directions. So this problem is a little bit different from the one we did previously, because the one we did previously, you had two objects traveling in the same direction. Because one had to catch up to the other. This problem is a little bit different. It says a cruise ship left Hawaii. Let's label that H for Hawaii. The cruise ship, let's call that C, left Hawaii 10 hours before the submarine did. Let's call that S for submarine. The ships traveled in opposite directions. The submarine traveled at a rate of 10 miles an hour for 1 hour. So all these problems we've said earlier are distance is equal to rate times problem. They tell you that the rate of the sub was 10 miles per hour. 10 miles per hour. And it tells you that the sub traveled for a time of 1 hour. So you're able to calculate the distance that the sub traveled, the hours cancel, to be 10 miles. The sub traveled for 10 miles. They desire in this problem, they say that after this 1 hour, they gave you the time was 1 hour, after this time the ships were 285 miles apart. So this distance from here to here is 285 miles after an hour. So they desire what was the cruise ship's speed. All right, so again, the way you're going to get speed, this whole lesson today is a lesson in calculating distances, rates, and times. Distance is equal to rate times time is that relationship. So the distance, hopefully you can see that the distance that the ship traveled was 10. From here to here, this distance was 10. But they told you that after an hour, the ships were 285 miles apart. Well, if the submarine traveled 10 and this entire distance was 285, well, the distance that the cruise ship traveled had to be the difference between 10 and 285, which is 275 miles. 275 miles. All right. So now you know that that's equal to the rate, which is unknown in this problem. The time, according to this, it says that the cruise ship left 10 hours before the sub. So this cruise ship was on the water for 10 hours before the sub pulled off. So what that means, if the sub was traveling for an hour and the cruise ship left 10 hours before that, the time that the cruise ship was traveling is a total of 11 hours. Because the cruise ship left 10 hours before the sub. The cruise ship was on the water for 10 hours before the sub pulled off. The sub was traveling for an hour, so you can get the time that the cruise ship was traveling, which would be 11 hours, 10 plus 1. So now what you have is you have an algebraic equation. You have 275 is equal to r times 11. You're going to divide by 11 on both sides. And I've done that already. You get a rate of 25 miles per hour. 25 miles per hour. All right, final answer. All right. So notice the difference between these two problems. Here you're traveling in two different directions. Over here you're traveling in the same direction. You could just set one distance. You could set one distance equal to this. This distance was 120, and so is this distance 120. Over on this problem, here the distance was 10 miles, but here the distance was 275. So two different kinds of problems that you'll experience. And this is why I think you find these problems somewhat common on the different standardized tests. They require a variety of different skills. First skill that you had to be able to perform to be successful on this kind of problem is draw a good diagram. Draw a good diagram. The second thing that you'll discover on this problem is you had to perform a little bit of algebra. You had to have some type of understanding of algebra. And then finally, you had to be able to understand this is a distance is equal to rate times time problem. All right? And that's what you find on a lot of different standardized tests. You'll find on the ACT, PSAT, SAT, GMAT, all these types of standardized tests. In one problem, you'll find that you have to possess a variety of different skills in one problem.